In this video, we're going to learn how to graph cubic functions. So what is the graph of each cubic function, and then describe the graph, including end behavior, turning points, and increasing and decreasing intervals. So polynomials have this way of curving through the space. So we're going to try to find out where it's curving at and everything, but since its behavior can be so unique in so many different ways, oftentimes we have to resort just to plugging in points to get an idea of what the graph looks like. So for y is equal to 1 half x cubed, let's start by plugging in these values, -2, -1, 0, 1, and 2. When we plug in -2, we get y is equal to 1 half times -2 cubed. -2 cubed is -2 times -2 times another -2, which will give me 1 half of -8, because 3 negatives still remains negative. And half of -8 is -4. So there's my first y value. So my first point I can start to graph is -2 for x, -4 for y. Now next up I'm going to plug in -1. So y is equal to 1 half of -1 cubed, which means 1 half of -1 times -1 times -1. 3 negatives is still a negative, so I get -1. And then half of -1 is -1 half. So I have another point at -1, -1 half. I'll plug in 0. So 1 half of 0 cubed. So that's 1 half of 0 times 0 times 0, which is still 0. And 1 half times 0 is also 0. So we have another point at 0, 0. And then we'll plug in 1. Y is equal to 1 half of 1 cubed. So 1 half times 1 times 1 times 1. So it's 1 half times 1, which gives me 1 half. So a point at 1, comma 1 half. And then y is equal to 1 half of times 2 cubed. So that's 1 half times 8, which gives me 4. So another point at 2, 4. So now I'm going to use what I know about end behavior to help me sketch this graph. Because right now I'm seeing that it looks like there's like a little bend in it, but let's see if that's correct. So knowing what I know about end behavior, there's only one term. So we're going to go based off that one term. Now the coefficient is positive, so I know that it should go up to the right. And since it's an odd power, they should go in opposite directions. So if it goes up to the right, it should go down to the left. So as x goes towards negative infinity to the left, y goes towards negative infinity down. And as x goes towards positive infinity, which means to the right, y also goes towards positive infinity, which means up. So as I go to sketch this graph, I just need to make sure I end up going up and I end up going down. So if I follow this curve of points as best as I can, I get my first semblance of a cubic graph. I can see here that if I want to talk about turning points, it doesn't really turn around and go back down. It just kind of keeps going up. So there are no turning points. And then clearly this graph's always going up from left to right. So we say it's increasing the entire time. So the function increases from negative infinity to positive infinity. And that's focused on the x variable. So negative infinity is less than x, which is less than positive infinity. Now let's look at another example. So now let's introduce another term with it. So this is my polynomial, 3x minus x cubed. And to start off, I'm going to put that in standard form. So we have negative x cubed plus 3x. So I can actually start off by finding that end behavior and keep that in mind as I graph. So the leading term is a negative term. So if it's negative in front, that means I know it's going to go down to the right. And since it's an odd power like the previous one, it should go in the opposite direction to the left. So it'll be up and down. So I know it's going to go up to the left and down to the right in some way. So keep that in mind as we graph. So first, we'll start by plugging in these values. Plug in -2. So 3 times -2 minus -2 cubed, which is 3 times -2 is -6, minus -2 times -2 times -2, which is -8. So -6 plus 8 would give me 2. So I have a point at -2, 2. Now let's plug in -1. I get y is equal to 3 times -1 minus -1 cubed. So it's 3 times -1, which is -3, minus -1 cubed, which gives me -1. And that ends up giving me -3 plus 1, which is -2. So I have another point at -1, -2. Now I'll plug in 0, and I'll get y is equal to 3 times 0 minus 0 cubed, which just looks like 0 minus 0, which will give me 0. So there's another point at 0, 0. And then y is equal to 3 times 1 minus 1 cubed gives me 3 minus 1, which is positive 2. So I have a point over here at 1, positive 2. And lastly, I'll plug in 2. So y is equal to 3 times 2 minus 2 cubed, which gives me 6 minus 8, which is -2. So 2, -2. So now we'll go through and try to graph this. So following the points, I know it goes up to the left. So I'll start up high as I go through this first point on the left because I want that end behavior to be up to the left. Now the next point I need to go through is this point going left to right. So I have to keep going down. But then the point after this is above it, so I need to start curving as I go down to curve back up to go through the next point. You'll see here I'm going to kind of connect the dots with a curvy line. And this one goes through that point, and then again it curves and goes back down to get to the next point. And then I know it continues to go down all the way to the right, so I'll just continue that arrow down. So now looking at this, I can see that there's my end behavior. We have 2 turns in it, which we're about to get to a fact about that. And I see I go decrease for some of it and increase for a little bit of it. So if I were to describe all this, there are 2 turning points. So one's at -1, -2, or around there. Finding these by hand can be really tough. So we'll just go with what it looks like. And over here looks like that 1, 2, or 2 turning points. So we'll write there are turning points at -1, -2, and 1, 2. Now one thing I forgot to do with my end behavior is write it out with this little limit form, I like to call it. So you can say as x approaches -infinity, the left side, the y values go up. And as x approaches positive infinity, the right side, the y values go down. And lastly, we'll talk about where it increases and where it decreases. So we can see here that the graph decreases from -infinity to x equals -1. And again, that would look like this as an inequality. The function increases from -1 all the way to 1. You'll see it goes upwards. So -1 to 1. And then the function decreases again after 1 off into infinity. So I'm going to go back to this point of turning points. If you remember quadratics, they often had one turning point where it went up and then it went down. And for cubics, you'll see two turning points, or 0 as we saw earlier. So you'll often see that whatever the degree of your polynomial is, you'll have at maximum one less than the degree of turning points. You could have less. Sometimes it just kind of swerves instead of turning completely. So that's another good way to keep good thing to keep in mind when you're graphing polynomials, so you can know how many turns you can possibly have. And that is how you graph cubic functions.